I'll read the question for you. We have these sort of two intersecting triangles. This is getting to be a bit of a theme, right? In the figure shown, AE and BD line segments intersect at point C. Which of the following additional pieces of information is not, if you see a word capitalized, underlined, or italicized, or bolded, you highlight it. Don't just take their emphasis for granted. Flag that for yourself. Which of the following pieces of information is not sufficient to prove that ABC is similar to EDC? Okay, so let's again label a fact that we labeled on the last one of these questions. Those two angles are the same, vertical angles, right? The angle ACB is equivalent to DCE. And if that sounds like a fact worth proving, then you should go back and watch the previous videos. I'm going to keep moving here. We want to show what is not sufficient. The reason I'm flagging that word is it's very easy halfway through this question to forget about the not. It's much harder if you see it sort of highlighted for yourself, if you've actively drawn your attention to it. Don't be passive. Don't just say, oh, I won't forget. You might not forget 90% of the time, and still that would mean 10% of the time you're losing points. Okay, AB is parallel to DE. You're going to start getting familiar with this fact because they brought this up on a previous question. This was sufficient. Why is it sufficient? Because of the so-called Z rule. Again, I won't belabor the point. You could think about this as a Z where angle B and angle D are the same, right? Here's my sort of sideways Z. Similarly, I can do the same thing with a different color and say I've got a Z like this, sort of a weirdly oriented Z, but here are my two interior angles. So this fact is certainly sufficient. By the way, if I'm rushing, I would go to C and D, because on a which question where you have to consider the options, you can't do it on your own, it's likely that they're going to make you consider facts that are that are not the right answer first. Right? So maybe I'll do that now. This is an important point. I should slow down here. Which of the following pieces of information? That implies that without the answer choices, you could not answer this question, right? That you have to consider the answer choices. You can't just go do some math, right? Some questions you could just go do some math and then check to see if your answer matches an answer choice. Not so here. Well, that means that because they're asking you to consider the answer choices, a good strategy for wasting your time would be to put the right answer, or the answer that you're looking for, near the end of the set, right? You're gonna save time more than you waste time with this strategy. Okay, highlighting the word not again. Let me go down to answer choice D. The measure of A. Again, let's kind of mark these. The measure of A is equal to the measure of B. Okay, interesting. And the measure of D is equal to E. This is such an interesting fact. And this is an example of a question or a fact in which it really pays to throw values in here. These values don't have to be, you might feel like one set of values is lucky, and therefore you want to pick a different one. We'll call this something, fairly easy to use, but maybe not super special. Like 30s, 60s, and 90s are really special in triangles. So I made angle ACB and DCE both 40, right? Like we said, we know that that's a fact. Okay, well, I could do a little math to now figure out A and B. Since they are equal, you could say something like, 2x. You call these both x if you like. And we'll call these both y. That's what answer choice D is talking about, right? The angles are equal. 2x plus 40 now. 2x plus 40 equals 180. 2x therefore equals 140 by subtraction, and then dividing by 2, x is 70. Okay, well, it may have already occurred to you what I'm about to do. If I know x is 70, now let's go over and talk about y. Well, it turns out 2y plus 40, the three angles of our triangle on the right, are equal to 180. That might be, by the way, a good stopping point. If you know 2x plus 40 is equal to the same thing as 2y plus 40, turns out y is the same thing. If that's not totally clear, keep going. 2y by subtraction is equal to 140. I subtracted 40 from both sides. Now I'll divide by 2. Y is 70. Right? We've got it. Y and x are the same. It turns out this very oblique fact is sufficient. And by the way, I circled it as if it's the right answer. Remember, we're looking for what's not sufficient. D turned out to be sufficient. Right? Okay, so I'll clear this because we're running out of space here. A and D are both sufficient. We haven't considered C yet. AB is equal to the length of DE. By the way, this is the exact same fact. I'll call this length L and L. This is the same fact we saw in a previous one of these questions. The SAT repeats itself. If you see these questions over and over again, you can say, look, this fact is insufficient. Knowing a proportion of the angles gives us the equivalent side lengths does not tell me anything about the other angles, which is what we care about. We care about similarity, meaning all the angles are the same. You could easily mess around with these figures and create a situation that does not prove this fact. Maybe the most solid ground to be on is to consider B next, right? Considering all four of the answer choices is a clear way. If you can say that three of them do prove similarity, you could be very confident in picking C. Well, you know, I mentioned going to the end first. So if you feel confident, you could just pick this one and be done. You'd be right. Let's talk about B, however, just to prove our point. These angles are the same still. D is equal to B. Okay, well, here's D right here. I'll use a different color. And B. Again, I think numbers can help. And again, you could pick your own here. I'll pick a different set here. Let's say this is 70 degrees. Okay, that makes this 70 as well. Now, if these are equivalent, let's be weird about it and make it 100. If this is 100 and this is 100, then a triangle is 180 degrees. There's only 10 degrees left here. So 170 between these two angles means 10 degrees left here as well. Of course, now we've proved similarity. You could throw your own numbers in here. Similar, similar, and similar. C is the one that doesn't work. Again, the predictability of the test, you can leverage that to say, I've seen this fact be insufficient on previous questions before. But notice how I'm grounding my thinking in real values. You can play with values. It's totally allowed. It's something that we don't do in math class very often because, rightfully so, the teachers want you to understand the principles. What we're trying to do is get the questions right on a test, right? So you can use values to bolster your reasoning, and indeed you should. If you're not doing so, you're going to get lost in abstraction, and you're not going to move as quickly as students who are able to use values as a part of their reasoning.